You are starting to watch your last lesson for Chapter 1. Congrats! Today we're going to be talking about the distributive property, which I like to call the rainbow property, and the do not be greedy property. First, what is the distributive property? It's when there's multiplying outside of a parentheses. This is algebra. These are some real-world examples. As you can see these two real-world examples, the number can be written in the front or in the back. So if I were to give you something like this, what that is saying, whenever there's something written, a number right next to a parenthesis with nothing between, that's always being multiplied. So I'm going to distribute, which is multiplying to everyone on the inside. So in this case, I would have 4 times x, which is 4x. And I would have 4 times 2, which is 8. So that becomes like so. So that's one example of a distributive property. You could have also have x minus 3. And let's say we have a negative 4 back here. This is still being multiplied, and there's still 2 terms on the inside of this parenthesis. 1, 2. So you still have to distribute that inside. So the first one I have is x times a negative 4, which becomes a negative 4x. And when I distribute this negative 4 to this 3, you have to be very careful with subtraction. Remember when I had adding and subtracting positive negative numbers, I always changed that subtraction to a negative. So now I know when I multiply negative 4 times negative 3, that becomes a positive 12, and that would be my answer. So again, a few more practice problems. For the top one, it's written on the outside, so I multiply it up front. So this would become 3 times x, which is 3x, and 3 times 8 would give me 24. And that's my final answer because I do not have an equal sign, so I'm not solving for anything. For B, this is, again, you should change your subtraction to negative if you have a difficult time. And you multiply in negative 7 times 5 would give me a negative 35b. And negative 4 times negative 7 would give me a positive 28. And that would be my final answer. Right now you should pause the video and try these next 4 by yourself. So here are the answers to these problems. The first one, I distribute the 5 and I got 5x plus 35. The second one, even though you have a fraction here, you can still multiply. Above, I showed my work of how you would multiply with a fraction. So that final answer becomes 36 minus 2t. Because once I multiply across, this becomes a negative 12, and this becomes a positive 6, which gives me the negative t. And I wrote it with subtraction. C, it's just multiplying with decimals, which you can always do. And that was 1.2 plus 3.3c. And the last one, first I changed my subtraction to negative, and I have negative y times 2y. That would give me negative 2, because negative 1 would be right here, times 2 is negative 2, and that's y times y, which we write as y squared. And then negative 1y times a negative 1 gives me a positive y. And those would be my final answers. Here I'm going to show you the long and short way to simplify fractions. This whole thing is saying divide by 5. So one way you could do this is to take out the 1/5 and then distribute the 1/5 in, and this would be your final answer. A shorter way to do this, if you look at A, if this whole thing is divide by 3, you have to make sure to divide each term. Remember, term is in between positive and negative signs by 3. So this answer would be 4x divide by 3, and I still have subtraction, 16 divide by 3. And that would be my final answer because I cannot simplify anywhere else. However, on the second one, again, you could just do 11 divided by 6 plus 3x divided by 6. Whenever you can simplify, you should. In this second fraction, I can simplify this to 11 over 6 plus 1/2 x. Right now you should pause the video and try to do the next two problems by yourself with simplifying. So once you divide it out, these are my next two problems, but you have to make sure to simplify it. The 15 and 12 both can be divisible by 3. That's where the 5/4 come from. And the 6 and 12 can be both divisible by 6. For D, 4/8 can be divisible into 1/2, and 2/8 would be 1/4. Remember, you keep this subtraction as is. Now this problem, whenever there's a negative out in front, you should always think of that as a -1. So I could write the 1 in if you wish to. This is a 1. And then I would still have to distribute that negative sign. So this would become a -2y. And here I have a -1 times a -3 because subtraction's like negative. And that's a positive 3x. You should pause the video and attempt both C and D by yourself. So these are my two answers. Now another way to think of this, and like I said, subtraction and -1 is like the opposite. So really you're just writing the opposite of the two terms. This was positive and now it's negative. This was negative and now it's positive. So when you multiply by the -1, it's just writing the opposite. Here are a lot of definitions, and if you want to write them all down, you can. However, you do not have to. When looking at this problem up here, I'm going to go through and show you. A term is anything that's separated between a positive or subtraction sign, so plus or minus. So these are all terms within this problem. Terms are always in between addition and subtraction. A constant is any number that's all by itself. This is my only constant because the number has no variable. And coefficient is the number in front of the terms with the variable. So as you can see, we have three different coefficients. This is the number 6 in front of this variable, -5, and 3. For these next problems, you should combine like terms. You only combine like terms if they're on the same side of the equal sign. So for this first problem, as you can see, both of these have 2 x's, so these are like terms. So if you do have like terms, then you add the coefficient, and again, the coefficient is the number in front of the variable. So 8 plus 2, and I'm adding because there's an addition sign in between, would give me 10, so this would be 10x squared. So for B, the first thing I tend to do is change any subtractions to minus. So those I'm changing to minus. And then I look throughout the problem and see what are the like terms. And I put the same symbol below the same type of variable. So here's a 5x. So I'm looking for any other x's. Here's another x. Here's just a constant, which is just a number. Here's just a number. And then the 6y is all by itself. So now when I combine my like terms, I have a 5 that goes with a -3 because I switched the subtraction to negative, so that would be a 2, and I have an x with there. I have a 6y, and then I combine my last two numbers, which is -3 and 4, which is +1. You typically will write your numbers or your constants at the end of your equation. So for the next three problems, A through C, you should solve and try to simplify. So for this first problem, I changed my subtraction to negative, and that would be a 3 plus a -1. Again, if there's no coefficient, you should always think of that as 1. That's 2y. For the second one, I also changed my subtraction to negative, and since they're the exact same, here I have 1m and 4 n's, here I have 1m and 4 n's, then I can combine them. And a negative plus a negative is going to give me a larger negative. And the last one, I know that the first and last term are like terms because there's 3 y's and 1 z. Here's 3 y's and 1 z. This has 1 y and 3 z's. So when I combine the first and last, I got 8y cubed times z minus 6 y z squared, or z cubed, sorry. These are not alike because there's 3 y's here and 1 z, and over here I have 1 y and 3 z's. So those are not alike. You should fill out the Google Doc and submit. And our test is coming up next week on the 17th or 18th. Have a wonderful day.